Hello everyone, and welcome to this virtual briefing and an update on the PFAS restriction proposal, which will have a special focus on F-gases. My name is Audun Heggelund, and I work in the Norwegian Environment Agency, and my role in this is that I coordinate the work from the Norwegian side with the restriction proposal. And together with colleagues from Denmark, we are also in lead of assessing F-gas applications. This talk I will give an introduction to PFAS in general and the restriction proposal, and I will explain how F-gases are relevant for this. I will also explain the basics of the restriction proposal process, and this is because it has been commented that parts of the F-gas sector is relatively new to the REACH regulation, and general information is needed, as well as that we would point out the points in the process where the stakeholders have the opportunity to provide information from their side. So currently, 5 different countries are together developing a restriction proposal for PFAS. This is Germany, the Netherlands, Denmark, Sweden, and Norway. This is going to be a restriction proposal under the EU's chemicals regulation REACH, and it will be a very broad restriction proposal, and it is intended to cover all PFAS in all applications, but we are expecting that there will be a need for certain derogations from the restriction. Originally, it was planned for submission of the proposal in July this year, but this has recently been delayed until January 2023. And the reason for this is that we needed some more time to assess the different applications of PFAS, as well as do the necessary analysis for a solid restriction proposal. After submission, the proposal will go through a standard evaluation procedure, and a decision will be made by the European Commission with the member states. And probably this will happen sometime during 2025, most likely. And one very important point is that the restriction proposal is currently in development. That means that we cannot go into specific details of the proposal as nothing has been finally decided until the proposal is actually submitted. PFAS have very broad applications and are used in very many different products. For example, PFAS may be used in ski wax and glider for skis. They may be used in cookware for providing a non-stick surface in waterproof clothing. PFAS may also be used in food packaging, like for example, microwave popcorn bags. They are sometimes used as refrigerants, and the last example is firefighting foam. But PFAS in firefighting foam is the subject of a different restriction proposal that has recently been submitted by ECHA. From the chemistry perspective, there is large variety among PFAS. Some PFAS are large molecules, some are smaller, and some PFAS contain a large number of fluorine atoms, while others contain just a few. This is the current working definition of PFAS in the group. A PFAS is any substance that contains at least one fully fluorinated methyl or methylene carbon atom. That is, the CF3 or CF2 group should not be directly attached to any hydrogen, chlorine, bromine, or iodine atom. And this is in line with the recent definition of PFAS from the OECD UNEP Global PFC group. And it appears that there is at least between 5,000 and 10,000 different PFAS substances. This is an outline of the underlying concern as we see it in the PFAS restriction proposal. The main concern is the persistence of PFAS, which applies to the whole class. Persistence means that the substances are very stable in the environment and do not degrade for a very long time. Either PFAS are persistent themselves, or they degrade to other PFASs, which are persistent. As supporting concerns, we have the bioaccumulation potential on the one hand, and the aqueous mobility on the other hand, as well as toxic effects. And bioaccumulation is that going up the food chain, the substances accumulate for each step, and you find the highest concentrations in the top predators. Mobility is the tendency for a substance to follow the waterways and stay in water for a very long time. And there is a gradual transition from bioaccumulation, which is usually related to the long chain PFAS, to mobility, which is most often a property of shorter polar PFASs with high water solubility and low adsorption potential. And there is an ever-increasing knowledge base for toxic effects of different PFAS, which includes, for example, effects on the liver, increased cholesterol, and reduced immune response. And in addition, cocktail effects come into play, as exposure often is to several PFAS simultaneously and not to single substances. And at the bottom of this slide, I have included a link to EEA and more elaboration on health effects of PFAS. And now over to the role of F-gases in the PFAS restriction. The key point is that some F-gases used as refrigerants are PFAS. And F-gases are often linked to their contribution to global warming, depending on their chemical structures and properties. And the global warming potential of F-gases is regulated through the F-gas regulation. However, some F-gases are also related to other concerns, and these concerns are not regulated in the F-gas regulation. This slide shows simplified version or simplified representation of F-gases. On the left-hand side, we have the old F-gases. They contribute to global warming, and they are regulated in the F-gas regulation. While on the right-hand side, we have the new F-gases, like the HFOs, and they may contribute to other effects than global warming through, for example, their degradation products and substances that may precipitate with rain and snow, like, for example, TFA, trifluoroacetic acid. And as these concerns are not sufficiently addressed in other regulations, they will be included in the restriction proposal for PFAS. In the work with the restriction proposal, we have collected and compiled information about different applications of F-gases, including refrigeration, foam-blowing agents, propellants, solvents, cover gases, and fire suppressant agents. Volumes and emissions have been largely collected from the reporting to the Climate Convention. And from the pie chart on the left, you can see the relative sizes of the different applications. And overall, F-gas applications are among the largest applications of PFAS when it comes to volumes and emissions. If you take a look at the current working definition of PFAS and compare with some F-gas chemical structures, we get this picture. And again, the working definition of PFAS in our group is that a PFAS is any substance that contains at least one fully fluorinated CF3 or CF2 group that is not directly attached to a hydrogen, chlorine, bromine, or iodine atom. But we should keep in mind, of course, that this is the current working definition and it may be changed further down the process. On the left-hand side of this slide, we have some substances or F-gases that are outside of the working definition, while on the right-hand side, we have some F-gases that are within the current working definition of PFAS. Starting on the left, we have R32. This contains a CFT group, but this is directly attached to two different hydrogen atoms, so this is not a PFAS. R13 contains a CF3 group that is directly attached to chlorine, and again, this is therefore not a PFAS in the PFAS restriction proposal. R152A contains a CH3 group to the left and a CF2 group to the right, and this CF2 group is directly attached to one hydrogen atom, and R152A is therefore not a PFAS. On the right-hand side, we have TFA on the top. This contains a CF3 group. This is not attached to either a hydrogen, chlorine, bromine, or iodine atom, but to a carbon atom, and therefore this is a part of the PFAS scope in the restriction proposal. HFC 134A contains a CF3 group on the right-hand side or on the left-hand side of the molecule. This is directly attached to carbon, and therefore this is a part of the PFAS scope. And the bottom compound contains three different CF3 groups and one CF2 group, all attached directly to carbon, and therefore this is clearly a PFAS structure. This slide shows some degradation pathways for F-gases that can be found in the scientific literature, for example, in the report that I have linked up on the bottom of this slide. In the red circle in the middle of this slide, we see TFA, trifluoroacetic acid. This is a degradation product from several different F-gases. And when this is forming in the atmosphere, it quickly dissolves in droplets and precipitates with rain and snow. And we can see that the top left three different F-gases all degrade to TFA in the atmosphere. HFC 134A degrades to TFA in 7 to 20% yield, while HFO 1234YF degrades essentially 100% to TFA. On the right, we have a different HFO substance, HFO 1234ZE. This has a different main degradation pathway. It degrades via trifluoroacetaldehyde and to CO2 and HF. Well, there are some secondary degradation pathways as well, and in the report that I've linked up, you can see that up to 10% TFA may also be formed from atmospheric degradation of this particular HFO substance. While it is not only TFA that is a degradation product of concern among F gases, on the bottom we see that HFE 7100 may degrade to the substance PFBA in the atmosphere. And this is closely related to TFA, but it has a longer perfluorinated carbon chain in the structure. The atmospheric concentrations of some F gases have been recorded over time, and we can look at the time trends. This curve shows the atmospheric concentration of HFC 134A as measured at the Zeppelin Research Station in Spitsbergen, Norway. And we can see that from 2001, over 20 years, there have been a six-fold increase in the atmospheric concentrations of this substance. And there is nothing that indicates that this curve is about to flatten out. And from the previous slides, we have seen that this substance may degrade to TFA in up to 20% yield. This slide shows some of the evidence from the literature for increasing concentrations of TFA in the environment. From a study in Denmark, 2021, TFA was detected in almost all of the groundwater samples collected all over the country. And TFA was also found in drinking water sources. In Beijing, in the period 2002 to 2012, a 17-fold increase in TFA in urban surface waters was detected, while TFA in tap water increased from not detected to 155 nanograms per liter. That is not a low value. In modeling studies from Europe, researchers looked at the transition from HFC 134A to HFO 1234YF in air conditioning cars. They looked at equal volumes of these two refrigerants. And from the previous slides, we know that 134A degrades to up to 20% TFA in the atmosphere, while 1234YF degrades to essentially 100% TFA. And this represents a five-fold increase. But in addition, 1234YF degrades much more quickly than 134A. So the degradation product TFA forms and precipitates much more closely to the source. And the models indicated that there may be as much as a 250-fold increase in TFA concentrations in Europe following from this transition to 1234YF in air conditioning cars. So back to the assessment of F-gas applications. A key point in the assessment is the availability of fluorine-free alternatives to the different F-gas applications. And this was also a question asked specifically in the second stakeholder consultation that was run last year. We received more than 170 comments to this consultation, both from industry as well as NGOs, and also from both within and outside of Europe. And we are currently looking into the comments received, and this will form a part of the basis for the restriction proposal going forward. And now a few words on the procedure with the restriction proposals. The legislation that applies in this case is the EU Chemicals Regulation REACH. And REACH is an acronym for Registration, Evaluation, Authorization and Restriction of Chemicals. A restriction is a tool for protecting the health and the environment from the risks posed by chemicals. It may be used to address the risk that is not adequately controlled and where action is required at the union level. Usually, restrictions limit or ban manufacture, placing on the market or use of a substance, but the restriction can also set out specific conditions such as technical measures or labeling requirements. The European Chemicals Agency, ECHA, is the agency that implements and manages the REACH regulation. And when we see a need to make a proposal for a new restriction, we develop a restriction dossier, also called an Annex 15 dossier. This is a relatively large document with a lot of different information, and it usually is thoroughly justified with many scientific references. The dossier contains information on, for example, substance ID and the chemistry of the entity to be restricted, information on hazard, effects, and risk. The different applications of the substance are described and assessed together with alternatives, and a large part of the proposal is a socioeconomic analysis of the impact from the different identified restriction scenarios. A restriction proposal is submitted on a specific date, and there are 4 different opportunities each year. The 13th of January 2023 is one such submission date. A short while after the submission, the public consultation starts. This is a 6-month consultation where stakeholders can comment on the restriction proposal and voice their points. And it is very important that stakeholders do this, as this is a key part of the restriction procedure. And the earlier the comments are submitted, the better. In parallel with the public consultation, the opinion development in ECHA's scientific committees start. The Risk Assessment Committee RAC has 9 months to develop their opinion on the restriction proposal, while the Socioeconomic Analysis Committee ECHA has 12 months, including a 60 days consultation of their opinion. A decision is made by the EU Commission with the member states, followed by scrutiny by the Council and the European Parliament. And starting from January 2023, a decision may be expected most likely sometime during 2025. If you want to know more about the restriction process, ECHA has very nice information on this on their web pages, which may be accessed at the link on the bottom of this slide. In particular, if you press the View Flowchart button at the top, you will be taken through all the different parts of the restriction procedure in a systematic manner. So this marks the end of this virtual briefing and update on the Universal PFAS Restriction Proposal and F-gases. We hope it was useful, and thank you very much for your attention.